Hi guys, today we will perform together survival analysis using SPSS. It's a very important analysis used mainly in the field of medicine to compare treatments and medicines, which one is better, which treatment is better and more effective for the patient. Let's start by introduction to survival analysis. What is survival analysis? Is a statistical method. We will discuss here the Kaplan-Meier method in this exercise. And this method is used to analyze time to event data. For example, if I'm comparing two medicines or two treatments, so the time to event here is the time to death. The event is my death here. How much time was I able to make this patient survive more? Key questions answered here. The probability of an event occurring at a specific time. For example, after 5 months, and for each treatment, what is the survival rate of each? We will see this in details in the exercise. What are the different factors impacting survival time? And what is the average survival times between different groups or different treatments? The key concepts in survival analysis, let's highlight the most important. Time to event, as I said, for example, if I am measuring the survival rate, it will be the time to death. And when you are making a survival analysis, and honestly based on my experience, you will always face censoring in survival analysis. What is censoring? Suppose that you gave a treatment for 50 patients, 30 out of them died, and for the other 20, either you lost the follow-up or they didn't die, or they died before you made your analysis. So these are called censored data, and these are presented in the data, but once we make the test to compare the two treatments or three treatments, whatever the number of treatments is, these will be excluded. In our lesson today, we will explain the Kaplan-Meier survival curve. We will perform this in SPSS. We will estimate the probability, the survival probability over time. We will make a visual representation of the survival rate, and we will use the log rank test to compare if these two curves indicating two treatments, if there is a significant difference between them. For later analysis, maybe not for this, not for today, we will perform Cox proportional hazards model and life table method. For the sake of this exercise, I chose a very simple data to perform the analysis in SPSS. Patient ID, as in any data, you have a unique ID for every patient, a unique name. This will be not used in the analysis, just for reference. Treatment, for example, here we will be comparing two treatments, A and B. The survival time, here the survival time from the time the patient took treatment A or treatment B, how many months did he survive? And the event, here as we said, our event here is the death, as we are analyzing survival rate. This will be coded mainly as 0 if the data is censored, and 1 if it occurred. And as I explained before, censored means that either we lost the follow-up with the patient, or he still did not die for the time that we are performing this analysis. This is our raw data in Excel containing 4 columns. Patient ID, which is a unique column. Every patient has a unique ID. Treatment, for this example, it's either treatment A or treatment B. Survival time in months, and the event occurred as we explained. It's either 0 or either 1. Okay, so now together we will perform the Kaplan-Meier analysis using SPSS. It's very easy steps, and I will make it very quick because the most important here is the analysis later on, how to analyze the results, as it's very simple to perform it. How to perform the survival analysis using SPSS. I go to Analyze, Survival, Kaplan-Meier, Treatment, it will be the factor, survival time is my time, and the event occurred either 0 or 1, it will be my status, and my event here is 1, because the values here are either 0 or 1. 0 for censored data and 1 for patients who died. Continue. Now, for the compare factor, I will choose the log rank test. In the options, I will choose in the plots the survival plot. Continue. Okay. So here are our results in SPSS. Case processing summary, survival table, means and medians for survival time, overall comparison using the log rank test, and this nice chart for comparing between treatment A and treatment B. This is my style in analyzing the data. I copy pasted the tables to a Word document, and I made the analysis here, this nice analysis in Word as a final report. Okay, so the first table is the case processing summary. For treatment A, out of overall 53 patients, 32 died and 21 either we lost follow-up or they didn't die. So this treatment A has 21 censored patients, which are 39.6% in treatment A. In treatment B, out of 47, 39 died and only 8 are censored, which are 17%. And overall, we have 29 out of 100. These patients are marked as censored, which make 29%. So this is the first table, the case processing summary. Second table is the survival table. Let's see it here in SPSS. Here, at every time, we have the cumulative proportion surviving at the time and the number of events. For example, after around 1.4 months in treatment A, 4 died, so the survival rate here is 92.4. After 3 months, these are censored. After 3.48 months, 7 died, and now the survival rate is 86.2. If we go to treatment B, at for example 3 months, 1 died, so the survival rate is 97.8. And what I mean by survival rate are the patients who are alive divided by the total number of patients. Let's see this analysis here in the table, in the survival table. So this survival table, I already gave you a few examples. For example, at time 5.5, for treatment A, the survival rate was 74.7%, where after 5.5 months, it was 61.3% for treatment B. So as an interpretation here, using this table, treatment A has a higher survival probability over the time compared to treatment B, meaning that treatment A live longer on average. So here we have as well the means and medians for survival rate. For treatment A, the mean survival time is 18 months. For B, it's 9 months. Look at the difference. The median, that's the 50% of patients in treatment A die at 13.38, where in treatment B, 50% of the patients die at 8.44 months. Mainly all that, these are the main things that you need to know about this table. I made a full analysis, but mainly these are the main significant points. And now for the most important, the log rank test. You see here that for the log rank test, the log rank test gave a p-value of 0.001, indicating the significance difference between the two curves A and B. And since this p-value is below 0.05, we reject the null hypothesis and conclude that there is a significant difference in survival between A and B, and we can judge that treatment A is much better than treatment B, as the survival rate is bigger, is higher, and the result is significant. And here, this is the curve. As you can see that treatment A is higher than treatment B in survival. Thanks, and I see you in another video.